The watt is a derived unit of power in the International System of Units, named after the Scottish engineer James Watt. The unit, defined as 1 joule per second, measures the rate of energy conversion or transfer. Definition: 1 watt is the rate at which work is done when an object's velocity is held constant at 1 meter per second against constant opposing force of 1 newton. In terms of electromagnetism, 1 watt is the rate at which work is done when 1 ampere of current flows through an electrical potential difference of 1 volt. 2 additional unit conversions for watt can be found using the above equation and Ohm's law, where ohm is the SI derived unit of electrical resistance. Examples: a person having a mass of 100 kilograms who climbs a 3-meter high ladder in 5 seconds is doing work at a rate of about 600 watts. Mass times acceleration due to gravity times height divided by the time it takes to lift the object to the given height gives the rate of doing work or power. A laborer over the course of an 8-hour day can sustain an average output of about 75 watts. Higher power levels can be achieved for short intervals and by athletes. Origin and adoption as an SI unit, the watt is named after the Scottish scientist James Watt for his contributions to the development of the steam engine. The measurement unit was recognised by the Second Congress of the British Association for the Advancement of Science in 1882, concurrent with the start of commercial power production from both water and steam. In 1960 the 11th General Conference on Weights and Measures adopted it for the measurement of power into the International System of Units. Multiples: for additional examples of magnitude for multiples and submultiples of the watt, see orders of magnitude. Femtowatt: the femtowatt is equal to 1/400,000th of a watt. Technologically important powers that are measured in femtowatts are typically found in reference to radio and radar receivers. For example, meaningful FM tuner performance figures for sensitivity, quieting and signal-to-noise require that the RF energy applied to the antenna input be specified. These input levels are often stated in dBF. This is 0.2739 microvolt across a 75 ohm load or 0.5477 microvolt across a 300 ohm load. The specification takes into account the RF input impedance of the tuner. Picowatt: the picowatt is equal to 1/1,000,000th of a watt. Technologically important powers that are measured in picowatts are typically used in reference to radio and radar receivers, acoustics and in the science of radio astronomy. Nanowatt: the nanowatt is equal to 1/10000000th of a watt. A surface area of 1 square meter on Earth receives 1 nanowatt of power from a single star of apparent magnitude plus 3.5. Important powers that are measured in nanowatts are also typically used in reference to radio and radar receivers. Microwatt: the microwatt is equal to 1/1,000,000th of a watt. Important powers that are measured in microwatts are typically stated in medical instrumentation systems such as the EEG and the ECG, in a wide variety of scientific and engineering instruments and also in reference to radio and radar receivers. Compact solar cells for devices such as calculators and watches are typically measured in microwatts. Milliwatt: the milliwatt is equal to 1/1000th of a watt. A typical laser pointer outputs about 5 milliwatts of light power, whereas a typical hearing aid for people uses less than 1 milliwatt. Kilowatt: the kilowatt is equal to 1000 watts, or 1 meter per second. This unit is typically used to express the output power of engines and the power of electric motors, tools, machines, and heaters. It is also a common unit used to express the electromagnetic power output of broadcast radio and television transmitters. In the USA and some other countries, 1 kilowatt is approximately equal to 1.34 horsepower. A small electric heater with one heating element can use 1.0 kilowatt, which is equivalent to the power of a household in the United States averaged over the entire year. Also, kilowatts of light power can be measured in the output pulses of some lasers. A surface area of 1 square meter on Earth receives typically 1 kilowatt of sunlight from the sun. Megawatt: the megawatt is equal to 1 million watts. Many events or machines produce or sustain the conversion of energy on this scale, including lightning strikes, large electric motors, large warships such as aircraft carriers, cruisers, and submarines. large server farms or data centers, and some scientific research equipment, such as supercolliders, and the output pulses of very large lasers. A large residential or commercial building may use several megawatts in electric power and heat. On railways, modern high-powered electric locomotives typically have a peak power output of 5 or 6 EMW, although some produce much more. The Eurostar, for example, uses more than 12 EMW, while heavy diesel electric locomotives typically use 3 to 5 EMW. U.S. nuclear power plants have net summer capacities between about 500 and 1300 EMW. The earliest citing of the megawatt in the Oxford English Dictionary is a reference in the 1900 Webster's International Dictionary of English Language. The OED also states that megawatt appeared in a November 28, 1947 article in the journal Science. Gigawatt: the gigawatt is equal to 1 billion watts, or 1 gigawatt equals 1000 megawatts. This unit is often used for large power plants or power grids. For example, by the end of 2010, power shortages in China's Shaanxi province were expected to increase to €6 GW, and the installed capacity of wind power in Germany was 25.8 GW. The largest unit of the Belgian nuclear plant Joule has a peak output of 1.04 GW. HVDC converters have been built with power ratings of up to 2 GW. The London Array, the world's largest offshore wind farm, is designed to produce a gigawatt of power. Terawatt: the terawatt is equal to 1 trillion watts. The total power used by humans worldwide is commonly measured in this unit. The most powerful lasers from the mid-1960s to the mid-1990s produced power in terawatts, but only for nanosecond time frames. The average lightning strike peaks at 1 terawatt, but these strikes only last for 30 microseconds. Petawatt: the petawatt is equal to 1 quadrillion watts and can be produced by the current generation of lasers for timescales on the order of picoseconds. One such laser is the Lawrence Livermore's Nova laser, which achieved a power output of 1.25 PW by a process called chirp pulse amplification. The duration of the pulse was about 0.5 ps, giving a total energy of 600 J, or enough energy to power a 100 W light bulb for 6 seconds. Based on the average total solar irradiance of 1.366 kW per meter 2, the total power of sunlight striking Earth's atmosphere is estimated at 174 PW. Electrical and thermal watts: in the electric power industry, megawatt electrical is a term that refers to electric power, while megawatt thermal or thermal megawatt refers to thermal power produced. Other SI prefixes are sometimes used, for example gigawatt electrical. For example, the Embalse nuclear power plant in Argentina uses a fission reactor to generate 2109 MWt of heat, which creates steam to drive a turbine, which generates 648 MWe of electricity. The difference is due to the inefficiency of steam turbine generators and the limitations of the theoretical Rankine cycle. Confusion of watts, watt-hours and watts per hour: the terms power and energy are frequently confused. Power is the rate at which energy is generated or consumed and hence is measured in units that represent energy per unit time. For example, when a light bulb with a power rating of 100 W is turned on for 1 hour, the energy used is 100 watt-hours, 0.1 a kilowatt-hour, or 360 kilojoules. This same amount of energy would light a 40-watt bulb for 2.5 hours, or a 50-watt bulb for 2 hours. A power station would be rated in multiples of watts, but its annual energy sales would be in multiples of watt-hours. A kilowatt-hour is the amount of energy equivalent to a steady power of 1 kilowatt running for 1 hour, or 3.6 mJ equals 3,600,000 joules equals 3.6 mJ. Terms such as watts per hour are often misused when watts would be correct. Watts per hour properly refers to the change of power per hour. Watts per hour might be useful to characterize the ramp-up behavior of power plants. For example, a power plant that reaches a power output of 1 MW from 0 MW in 15 minutes has a ramp-up rate of 4 MWh. Hydroelectric power plants have a very high ramp-up rate, which makes them particularly useful in peak load and emergency situations. Major energy production or consumption is often expressed as terawatt-hours for a given period that is often a calendar year or financial year. 1 terawatt-hour is equal to a sustained power of approximately 114 megawatts for a period of 1 year. The watt-second is a unit of energy, equal to the joule. 1 kilowatt-hour is 3,600,000 watt-seconds. The watt-second is used, for example, to rate the energy storage of flash lamps used in photography, although the term joule is generally employed. See also. Notes. References. External links: Nelson, Robert A., The International System of Units, Its History and Use in Science and Industry. Via satellite, February 2000. Online conversion, power conversion, Borvan, Gar. Copyright RAD. History of the electrical units.